All right, guys, behold the mighty normal curve. This is called the standard normal curve. And the standard normal curve has a x-bar of 0. And then positive numbers are to the right, negative numbers are to the left. And if we go one standard deviation to the right and one standard deviation to the left, this area should add up to be 68%. If we go 2 standard deviations to the right and 2 to the left, we should get 95%. And if we go 3 to the right and 3 to the left, then we should get 99.7%. This has a very well-known name. It's called the 68, 95, 99.7 rule. Yeah. So, I have a bunch of questions for you. How much area is to the right of one standard deviation? So that's going to take a little bit of figuring. So I want to know how much area is over here. How would we figure that out? Well, this here is 68. So David is saying take 100 minus 68. That gives me 32. And that 32 is split between left tail and right tail. So if we cut it in half, we get 16%. Okay? So I'm going to pause the video. You guys work on problems 1 through 8. All right. It is really, 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 really important you understand how the standard normal curve works. Okay? You have to get this whole idea of z-scores and test statistics and all of this. Okay? So if you don't understand this worksheet, please ask questions. Because if you don't get this, you're going to be in trouble the rest of the year. Okay? Now, the nice thing is, once it clicks, you can use that knowledge forever in this class. It's pretty much not going to go away. So, how much area is there between -1 and 2? So, how much area is in there? 68. So, how much area is in here? 34. 68 divided by 2, right? Okay, let me switch colors. How much area is in here? 95, right? So, how much area is in here? It's half of 95.
47.5.
So 47.5. Thanks, Garrett. And this question is just asking how much area is there right here? Easy enough. Okay. So what is that? 81.5. So 81.5. What did you guys get for 3? 97.5. So this is the area we're looking for, right? Well, how much is between here? 95. So how much must be there and there? 5. And we want to add this chunk to the middle, so this must be 2.5, and this is 95. So it's going to be 97.5. Wow. Except I wrote a 2. Okay. Kind of getting the hang of that? What did you get for 4? 15.85. Does anybody need to see why or how? You need to see it? Okay, I can do that. So we want this here, right? So if I draw the curve and I do plus or minus 1, this is 68, right? So that means that this piece is 34, right? Well, between 3 and negative 3 is 99.7. So how much area is there from here to here? Half of 99.7, what is that? 49.85, okay? And the red, this plus this must equal 49.85. So 49.85 minus 34 is going to be 15.85. Okay, so Gavin, what is 9 minus 4? Oh, good job. You got it right this time. Not 4. It's 5. You guys are great. I love it when kids say, "Oh, that was a stupid mistake," as opposed to those mistakes that make perfect sense, right? Oh man, that was a good mistake I just made. All right, how much is to the left of negative 3 standard deviations? 0.15. And notice we are using the symbol S for standard deviations. S is the symbol for the sample standard deviation. The parameter standard deviation is lowercase sigma, looks like that. Okay. What about between or outside of negative 2 and 2? That would be 5%. So if the inside is 95, how much is the outside? 5. Okay? All right. All right, so outside of negative 1 and 3. Well, this is 16%, right? 100 minus 68 is 32. 32 cut in half is 16. And this is 0.15. That's 100 minus 99.7 cut in half, 0.15. So that area is 16.15. Okay, we got to handle that. All right. Next up. For any normal distribution where we know the average and the standard deviation, we can calculate how many standard deviations a value is from the average. This number is called a test statistic or z-score. Suppose the class average on a test was, the average is 70 and the standard deviation is 15. How would we calculate that formula? So what this is asking is, if I draw my normal curve and I have 70 plus or minus 15, I want to transfer that information onto the standard normal curve, where 0 is in the middle and 1 standard deviation is there and negative 1 is there. Okay? How would we do that? Well, we take our value, which is p hat. Okay? So our p hat is going to be minus the average and divided by the standard deviation. That's the formula. Our sample value minus the average divided by the standard deviation. So number 10, if a student scored 85, what is their z-score? So we would take 85 minus 70, that gives us 15. Divide that by 15 and we get 1. What does z equal 1 mean? 1 standard deviation above, to the right, of 70. So the next question asks, is that an unusual score? No. No, that's a very normal score. Okay. Oh, I guess I should probably change the order of these. 17 should go first. So what if we worked backwards? 17 should go right here. I told you there'd be typos. So what is the value formula when the z-score is already known? Well, it's the opposite of this formula. So if I wanted to solve for p hat, what would I do? Times by the standard deviation, and then add the average. So the formula is p hat equals z times s plus x bar. So that's the answer to 17. Now, what does that formula actually do? Let's look at number 14. If you scored 60, it's in the right spot. I was wrong. Okay, let's do 18. If I told you your z-score was 1.3, what does that mean? You were 1.3 standard deviations, not away from, but higher than 70. Is that a good score? Yeah, that's a pretty good score, right? You did better than most people. Can a z-score be negative? Yes. Anything on the left side is negative. Great question. So 1.3 is a pretty good score, right? You did better than what, like 80% of the people. Okay? So how do I convert this z-score back into points on the test? I times it by the standard deviation, which is 15. So let me do that. What is 1.3 times 15? 19.5. What does 19.5 mean? You scored 19.5 points better than the average student. What did the average student score? So we add 70 to that, and I get 89.5. So that's what this formula does. You take the z-score and you multiply it by the standard deviation, and that puts the answer back into points. And then you add that number to the standard deviation. So your question was, can the z-score be negative? Yes. If it's negative, what does that mean about your score? Good. It's below average. So your z times standard deviation is going to be negative, which means you're on the left of 70. Great. Okay, I'll pause the video. You guys finish those problems. Okay, looking at this, what did you get for 12? That is a z-score of -2. Is that unusual? Yes. What did you get for 14? -0.67. Why is it negative? Because it's on the left side of 70. Good. And 15? That is a z-score of 2.46. Is that uncommon? Yeah, that's really uncommon. Okay. What about 19? -0.57. What does that give us as a value? 61 points. What about z equals 2.6? That is 109 points. And -3.8? That is 13 points. Okay, flip the page. I want you to go through 22 through 33. What did you get for 22? A calf weighing 500 pounds. 0.85. Why is that number positive? It's on the right side. More than 421. Good. What percentage of calves would we expect to weigh less than 328? Well, 328 minus 421 gives me 93, and I divide that by 93, negative 93, and I get a z of negative 1. So then I go back to my original table. How much is between 1 and negative 1? What percentage? 68. So how much is outside 1 and negative 1? 32. So the left side of that would be 16%. Okay? What would be the weight of a calf if z is negative 2.5? 188.5. Oh, that's a skinny cow. Or a baby cow. It's probably dead. Most people don't weigh the calves after they die. Most. All right. If a calf weighed 300 pounds, what is the z? Negative. What'd you guys get for 25? Negative 1.3. Okay. 26. 343.8. 27. 0.0. Oh, 0.3. There we go. Okay. What percentage of calves would we expect to weigh more than 235? So 235 minus 421 divided by 93 happens to be negative 2. So if we go up to this, how much is between negative 2 and 2? 95. So how much is outside negative 2 and 2? 5. So how much is over here? 2.5. And we want from here over 97.5. Okay? Is everybody understanding this? Okay. All right. What would be the weight of a calf with a test statistic of 3.3? 727. And more than 607? 2.5. Z-score if the calf weighs 600? 1.9. If the weight is negative 1.2, sorry, what is the weight if Z is 1.25? 537. And if a calf weighs 725, what is its Z? 3.26. Okay? All right. So you're going to need a Chromebook or a phone for this, and you need to search up Rossmann 1 proportion. Okay, that's the one that we've been using on our assignments. So you have a friend who says they can read minds. They ask you to think of one of the colors, red, blue, yellow, or green, and then they guess which color you're thinking of. When you play this game 50 times, your friend is correct 20 times. What would be the null hypothesis? So H naught is pi is equal to, what is the probability of winning if we just randomly guess? 0.25. Okay. What is the alternative hypothesis? H sub A, pi is greater than 0.25. Okay. So when I switch over to my app, what is my probability of winning? 0.25. And how many samples are in one session? 50. Okay. How many samples, not 550. How many samples should I take? A lot. 1,000 is usually enough. 10,000 will also work. 1,000,000 would work. Okay. So I draw the samples. All right. Now the next question asks, what is our sample value? 20. So this is 20. What is our z-score? Well, in order to calculate the z-score, I need the average and the standard deviation. I know the average. It's 20 out of 50, which is 0.4, right? So what is my standard deviation? Well, my standard deviation is probably going to be different from yours because you ran your own simulations. But there is a button here we can push, summary statistics, and it gives me a standard deviation of 3.15. Right here. Right above the graph it says summary statistics. So my z-score is going to be 20 minus, what is the expected value? So my mean is 12.523. Do I really expect 12.523? No, I expect 25% of 50, which is 12.5. So 20 minus 12.5 divided by 3.15. So using a calculator, my test statistic, 20 minus 12.5 divided by 3.5, I get 2.14. Is a z-score of 2.14 usual? No. So we got 2.5, 2.6. Did anybody get below 2? No, I'm kind of the low one. So if you have a z-score greater than 2, does that seem like you know what you're doing or you don't? That seems like you're not guessing, right? So let's calculate the area. Is my phone ringing somewhere? It is. So I'm going to plug in 20 right here. And run the area. And the area is 1%. So my p-value is 1%. Is there evidence to suggest that your friend can read minds? Yes. So do we accept the null or reject the null? We reject the null because my p-value is small, and we say there is evidence to suggest that your friend can read minds. Okay? Okay. Now, on the last one, you switch roles. Now you do the guessing, and you are only right 14 out of 50 times. Okay? So set up your null hypothesis and answer the questions 42 through 49. All right, look up here. I'm going to ask some really hard questions here in a second, and it will give us a good sense if you understand this or not. How is the null hypothesis in 42 different from the one above? It's not. It's the exact same. The null is the same. The alternative is the same. Okay. When I run this simulation and I type in 14, okay. So here's the hard question. What is this? What does that histogram represent? It's an observation of, so imagine you have a spinner and you say correct, incorrect, incorrect, incorrect. And you spin the spinner. Okay? And we spin the spinner how many times? 50 times. And we count the wins. Every win is every round of 50 is 1 dot on the histogram. Okay? So, when I played this, did 20 wins ever occur? It did. Did it occur very often? No. In fact, when I shaded over here, I got 1%. What does that mean? That was my p-value. So 1 out of 100 of my games of 50 spins had 20 wins or more. Let me say that again. Make sure you understand this. 1% of my 50 round games yielded 20 wins or more. So it does happen, but is it common? No. So if you were playing this game and you got 20 wins, would you feel that your spinner is broken? Yes, even though it's not. Right? Because it happened. We got some 20s, we got some 21s, we even got a 23. So the p-value is, what is the chance that a perfectly functioning spinner will give me a result of 20 or more? And in the first set, it was 1%. And we rejected the null. We said, we think your friend knows what's going on. Okay, so here, I get 37%. What does 37% mean? 30% of the time, a perfectly functioning spinner will give 14 wins or more when you spin it 50 times. Now, is 14 likely? Yes, it's quite likely. So does it seem like you know you can read minds? No. Now, this should frighten you a little bit because it's all just guessing, right? Can a perfectly functioning spinner get 20 out of 50 right? Yes. Can a perfectly guessing person get 20 out of 50 right? Yes. But that is so unlikely that there is evidence something is going on more than guessing. And that's how statistics works. Kind of scary, huh? Okay, finish up that worksheet, hand it in. Somebody with very pretty handwriting, hand yours to me so I can make an answer sheet. I disregard your comment.